Hey, what's going on, everyone? This is your video for the empirical formula of copper carbonate lab. And if you're thinking to yourself, copper carbonate, it doesn't sound right. Shouldn't it be either cuprous or cupric carbonate? You're right. And that's what we're going to figure out here today is in an unknown sample, what are we working with? So here are the things I need you to have out. In your lab document, you're going to take out page 4 that looks like this. There are a bunch of pieces of information that we need to go ahead and ascertain today, and we're going to use this for our write-ups. This is where we're going to collect our data today. Now in part 1, so part 1 is this big data table on top. Here's our game plan. What we want to do is figure out what type of compound is in here. And in the pre-lab, you saw there are 2 options for the unknown copper carbonate solution. You can see this is just a little powder. And so we want to figure out what compound is actually in here. Then in part 2, we've got a different one. This one is copper carbonate as well, but this is a different solution. So this is going to be for part 2 of the lab, and we'll see that in a moment. So looking at part 1, we are first asked to find a clean Erlenmeyer flask. So I'm going to aim the video down for us. We've got a clean 125 milliliter Erlenmeyer flask, and we're going to find the mass of that flask. So you can see that I've got a balance, I've got a fume hood for our reaction. I know you can't see it, but I'm going to throw this Erlenmeyer flask on the balance that has been tared. And I will tell you that the mass of that flask is 68.593 grams. 68.593 grams. So you guys can go ahead and record that. Now I'm going to go ahead and I'm going to add in some of the unknown copper carbonate powder into this flask. Now I'm aiming for a random amount between 1 and 3 grams. So anywhere between 1 and 3 grams is my target here. We'll go ahead and start adding our powder. Got about 0.5 grams there. There's about 1. And that takes us up to 1.459 grams. 1.459 grams of powder. So in your data table, we actually want the total mass of this. So if I take the total mass of my flask with the copper carbonate in it, that mass reads 70.048 grams. 70.048 grams. So you can do some subtraction there to figure out the mass of the powder inside of there. We've got the mass of both of these together. We've got the mass of the flask by itself. We do some subtraction. We can get the mass of the powder. Now the next thing we're going to do is grab ourselves a graduated cylinder, and I'm going to grab 20 milliliters of hydrochloric acid. So I'm going to measure in 20 milliliters of hydrochloric acid into my graduated cylinder. This is 2 molar hydrochloric acid. Now, instead of measuring the HCl by volume, we're going to measure it by mass. So I'll go for about 20 milliliters. There we go, meniscus up to 20. And I'm going to put that HCl graduated cylinder onto my balance. So when I do that, I figure out that the mass of the graduated cylinder with the acid in it is 67.216 grams. 67.216 grams acid in the graduated cylinder. Now we've got acid, we've got copper carbonate that's an unknown. We are going to combine these two, and when we do, let's see if we get a reaction to occur. Not sure if you can hear that, but you can hear fizzing going on. If I show this to you, there are a whole bunch of bubbles. If I swirl it, we can continue that reaction. So as I continue that reaction, what we're giving off is carbon dioxide gas. And I'm actually going to let this sit for a little while to continue generating carbon dioxide gas while we continue with other parts of the lab. So we'll come back to this in a moment. In the meantime, let's get some more data. So the graduated cylinder did have acid in it. Remember, I gave you a mass of the cylinder with acid. If I give you the mass of the cylinder, then we can get mass of the acid. So the mass of the cylinder by itself is 46.739 grams. 46.739 grams is the graduated cylinder by itself with the acid gone. So obviously if you do some subtraction, you can figure out the mass that was the acid. All right, so we've got some things to analyze here, right? We've got our flask. It has copper carbonate in it, the unknown. It also has acid, and there's a reaction taking place. The reaction has slowed dramatically, but there's still carbon dioxide being given off. So I actually want to continue to let this sit and let it continue to give off gas, and we'll revisit this in a moment. In the meantime, look down to the data table for part 2. So in the interest of time, I've already completed quite a bit in part 2. But what part 2 shows you is that it wants you to put together a certain volume of copper 2 sulfate stock solution. That's this container that has blue stuff in it. This is a solution of known concentration. And mixed with this, I've got various amounts of deionized water. So you can see in your data table that in the first test tube, I put in 10 milliliters of stock solution. In the second test tube, I put 8 of this and 2 of water. In the third, I put 7 of this and 3 of water. And so those test tubes, I'm going to show you here momentarily, end up looking like this. So over here is test tube 1, 2, 3, and so forth. And you can see that we go lighter as we go across the test tubes. And that makes sense because as we go across the test tubes, we have more and more water relative to the stock solution. Let me put a piece of paper behind this so that you can see things a little bit more easily. So there are the colors of blue. And what I want to do is show you an unknown sample so that we can make a comparison. So here is the kind of test tube rack that they want you to complete in part 2 of the lab. And these are all what we would call standards. So we know the concentration of each one of these, and you can see the color of each one. Here is the unknown. So this unknown I poured into a test tube, and we want to compare this unknown to all of these different solutions. So as you go down, see if you can figure out which one you think it is closest to. So I'll hold it right next to test tube number 6, test tube number 5, test tube number 4, test tube number 3, test tube number 2, and test tube number 1. And remember, you guys, I'm going to put that in front of the paper as opposed to the wood. So you guys do have the chance to go back and pause the video and see which one you think matched most closely. So ultimately our goal is to figure out, of the test tubes that I've just shown you, those 6, which one has the closest concentration to our unknown. And again, you can go back and pause the video and think about which one that might be based on the colors matching. Now, while that's been going on, our part 1 flask has had the opportunity to release gas. And so now that the reaction is complete, because we've let it sit for a while, I'm gonna get a new mass of this. So after we weigh this again, the CO2, remember, has gone away. So the new mass of this flask is 90.324 grams. 90.324 grams. And again, that should go up in your part 1 data table. And if you look at the mass of the flask plus the unknown plus the acid, and you subtract the mass I just gave you, that is the mass of carbon dioxide that's gone away. So that carbon dioxide difference will tell us the mass of carbon dioxide that we've left off, and then that will afterwards allow us to calculate the percentage of carbon dioxide that was initially in our unknown. So this is all of the data for the lab. There's quite a bit of calculations there are quite a few calculations that need to be completed. So you can look forward in the lab, but you now have all of the data necessary to go forth moving forward with those calculations.